Okay, ladies and gentlemen, I hope you're having a good either Wednesday or Thursday, depending on whenever you're watching this video. Reminder, just make sure that you're copying down all notes that I ask you to do, all problems that I ask you to do within the video. I will be checking those when I go check the homework on Friday. So make sure you're doing everything that you're supposed to be doing, and you should be fine. Good to go, ready to go. All right. Let's jump straight into the notes. All right. So, section 9.2, characteristics of quadratic functions. Characteristics of quadratic functions. So, in the section 9.1 video, we looked at what are quadratics and just basics about like, okay, it looks like a parabola. What does the equation look like? Okay, it has an x squared in it, things like that. Now we're going to take a look at, okay, what other unique things are going on within a quadratic? What other types of things that are always true in a quadratic? No, I don't want to link my phone. Bye. All right, so here we go. The first thing that we're going to look at a couple different things, but the first thing that we're going to look at are the zeros of a quadratic function. Let me get this all the way out of here. Okay, so when we talk about the zeros, just remember that a zero is basically just an x value that makes the equation true. There's my definition. Go ahead and write that down if you had not picked up on that already. A zero of a function is an x value that makes the function equal to 0. Now think about that. That's the x value is, the x value that makes the function, the y value, equal to 0. Now think about what that is. That's really just like an x-intercept, right? Something comma 0 is an x-intercept. So when I talk about zeros of a function, so the zero of a function is the same as an x-intercept of a function. So, you know, those two things are synonymous. An x-intercept and a zero are the same, really the same thing. You can think of those as the same thing in your mind, okay? The number that goes here is the place where it crosses the x-axis. Now remember that the x-axis is my horizontal axis, not my vertical axis, but my horizontal axis. Okay, so let's take a look here. Now, one other thing to point out, you might want to write this down too. A quadratic function may have 1, 2, or no zeros at all. And we'll talk about each type of those as we go along throughout this chapter. Okay. Again, pause wherever you need to, and then play when you can. Now, picking out the zeros from a graph, basically just taking a look at where it's crossing the x-axis. So for example, like this, it's crossing the x-axis 2 times. Look, I've got big red dots there for you. So the zeros of this quadratic are -1, 0, 3, 0. Notice that they are both in the form something, 0. -1, 0, 3, 0. You might also say the x-intercepts are -1, +3. Okay, I would accept them like this or as -1, +3. You can give it to me either kind. Okay, this is an example where a parabola is going to have 2 zeros. Okay, the bottoming out point, that minimum value, is down below the x-axis, so it's going to cross it twice. Let's take a look at an example like this. This is an example where I'm only going to have 1 zero. Do you notice how the bottoming out point is touching the x-axis? So I really only have a 0 at -1, -2, -3, -4. That's it. That's it. That's my zero of the function. Only 1, because the bottoming out point is sitting on the x-axis. Notice if a parabola has only 1 0, it's on the vertex, right? The zero is the x-coordinate of the vertex. Now, take a look at this. Notice how that it's now flipped over, and that apex point makes it so it's not even crossing the x-axis. So this is a parabola where we would have no zeros. No zeros. There'd be no solutions to the zeros. Okay. So it's pretty easy to see. You just look at where it crosses the x-axis. Remember, a 0 is where it crosses the x-axis. We don't really care about where it crosses the y-axis right there. We will talk about that when we start to graph them, but when we talk about the zeros of the function, It's where it crosses the x-axis. So another key point, another key, not point, but another key part of a graph is called the axis of symmetry. So go ahead and write down this definition. A vertical line that divides a parabola into two symmetrical halves, and that's key here. The halves must be symmetrical. Every parabola is symmetrical. So that means if it divides it into two parts, that thing that divides it into two parts, that line is called the axis of symmetry. The axis of symmetry always passes through the vertex of the parabola. So if I'm going to sketch out one real quick here, that axis of symmetry that we usually draw as a diagonal line should pass through that bottoming out point. That's a great drawing right there, isn't it? But you see what I'm getting at. If it's going to cleanly divide it into two, then it has to pass right through that vertex, that exact point that hits the middle of that graph. So take a look at the different options. Now we have 1, 0, 2 zeros, and no zeros at all, right? Well, if a function has 1, 0, the x-coordinate of the vertex is the axis of symmetry. So take a look at this one right here. And this would be a good thing to pause and write down as well, this whole box here. If it's got 1, 0, the axis of symmetry is really going to be the x-coordinate of the vertex. Notice here's the line, x equals 3. Now, a key point that I should bring up here, it's always going to be an x equals. Kind of went over my 3 there, but it's always going to be an x equals line for my axis of symmetry. That's always going to be true. X equals something. That's the axis of symmetry. Notice that the vertex is at 3, 0, and the axis of symmetry is x equals 3. If the function has 2 zeros, oops, let me get this out of here. If a function has 2 zeros, then it's going to go directly in between those zeros. So look, I've got -4 and 0 here, right? This -4 and 0. What's halfway between -4 and 0? -2. That's why you see the axis of symmetry at x equals -2. Okay, it's halfway between the zeros. So let's take a look. Let's practice that. What would be the axis of symmetry here? Well, think about it. Pause. Well, if it's going to go straight through, obviously this line would be the symmetrical line. So it's x equals, well, where is that? That looks like a -1. If you did not have the x equals, I would take off. That's really important that you have that x equals. What about here? Okay, so we got 2 zeros. Let's take halfway between. Well, what are my zeros? My zeros are at +1 and +4. Well, what's halfway between 1 and 4? That's 5/2, 2.5. Right? Halfway between 1 and 4 is 2.5. So it's x equals 2.5. Remember again, x equals. That's really important. Where would it be here? Well, we've got 2 zeros again, halfway between those. We've got -2, and we've got +4. Well, what's halfway between -2 and +4? Well, find the average of them. -2 and 4 divided by 2, 1. Count it up. 1, 2, 3 spaces away. 1, 2, 3 spaces away. So it's x equals 1. Again, make sure you have the x equals. Perfect. -1, -2, -3. Right? Lands right on that -3. So it's x equals -3. So that axis of symmetry, again, it's usually represented as a dotted line. When we start to graph, we will show it as a dotted line as well. But it's a couple things about it. Make sure it divides that parabola into two equal parts. You know what lines of symmetry look like. It should be that line of symmetry directly in the center. And should always be x equals. Always be x equals that line. Okay, now, how do we tell that if we're not given the graph? If we're just given the equation. Okay, so let's take a look at it here. Just using the formula. Here it is. Okay, now remember standard form where we had ax squared plus bx plus c? Those a's, b's, and c's are going to become extremely important pretty soon here, right? Very important, especially right now. If we're just given the equation, and again, this is definitely something we should be writing down. You don't have to write the example because we're going to do a bunch of them, but definitely write this down. You will need to memorize this formula. I will ask you this formula again and again and again and again and again. So it's x equals negative b over 2a. Well, what's b? The middle number, divided by 2a, the first number. So you got to take those two numbers out and then put them into the formula. Just like here. Take a look at this example. Negative b over 2a. Negative 4 over 2 times 2. 4 over 4 is 1, so it's negative 1. X equals negative 1. Let's take a look at some here. Find the axis of symmetry. Okay. Well, that's, again, x equals negative b over 2a. So let's identify what a and b are. Well, a is my first term, negative 3. B is my second term, 10. So that means I've got negative 3, negative 10 divided by 2 times negative 3. Now you can just go straight away to say negative 6 if you'd like, but now double negatives canceling each other out. I've got 10/6, which just reduces down to 5/3, and I'll leave it as a fraction. But make sure you have x equals. Okay, so there it is. So this graph, this line of symmetry, is around 1.67, 1.7. Take a look at another one here. If you feel confident with it, pause it and try it. So it's x equals negative b over 2a. Let's identify a and b. Negative, okay, so 2 is my a, negative 1 is my b. Negative b over 2a. Negative 1 over 4, okay. Negatives canceling out. 1/4, so it's x equals 1/4. Think about 1/4. That would kind of be hard to spot it on the graph just by the zeros alone, because we were doing easy ones when we said what's halfway in between the parabola. Well, 1/4 might be hard to tell. Definitely try this one on your own. Pause it and then jump back to it when you need to. Notice how I write down the formula every time? That's a really good way to memorize it. A is 1, b is negative 4. So we got x equals negative 4 over 2 times 1. So I've got negative 4 over 2. Okay, watch here. Negatives cancel out. 4 divided by 2 is 2. So it's x equals 2. And there's my answer. So just based on the equation alone, I can tell what the axis of symmetry is. Now, just based on the equation alone, I can also identify what the vertex is. And how we do that is, first step, figure out the x-coordinate of the vertex by finding the axis of symmetry. You can really just say, step 1, find the axis of symmetry. However you can, by using the zeros or the formula, whatever you do. Step 2, substitute the x-coordinate. What does that mean? That just means plug it in. Yeah, you take your result from step 1, you plug it in, and then you write it as an ordered pair, because remember, a vertex is always an ordered pair. Remember, the vertex, when I use that term vertex, that's just the bottoming out or topping out point. That's the vertex. That's the vertex. Make sure you write these down in your notes, by the way. All right, so find the vertex. So there's a couple different ways we can think about this. Let's try for the formula, for example. So step 1, find the axis of symmetry. So x equals negative b over 2a. Oops, that negative should go out front, but it doesn't really matter. It can creep up there if you wanted to. So a is 0.25, b is 2. So it's x equals negative b over 2 times 0.25. So that means we got 2 over 0.5, negative in front. So 2 divided by 1/2 gets us 4, and it's negative 4. X equals negative 4. Now, do I confirm that with the graph? Negative 1, negative 2, negative 3, negative 4. Is that halfway between those zeros? Yeah, I'd say that's true. So step 2, plug it in. 0.25, oops, I don't know why I put my parenthesis there. 0.25 negative 4 squared plus 2 times negative 4 plus 3. Okay, so I'm going to get my calculator real quick. Is there a quick calculator button? Oop, I'll just have to go here. So that means we got 16, and 0.25 times something is another way to say divided by 4. Oops. 16 divided by 4. Oh, duh, it's 4. So that means we've got a negative 4 minus 8 plus 3. Sorry about my weird 8. Looks like a 6 and a 0. Anyway, so we got a negative 12. That doesn't seem right. Oh, that's not negative. That's positive, right? Negative, any negative squared is a positive. So we've got a negative 4 plus 3 is a negative 1. Does that make sense? Look at we've got negative 4, comma, negative 1. The negative 4 comes from the x value. The negative 1 comes from the plug it in. My step 3 is write it as a coordinate pair. Is that confirmed by this? Negative 4, comma, negative 1? Yeah, there's my bottoming out point. Yeah. Okay, so you guys try one. Is there another one down here? Here it is. Pause here and try one on your own. Again, step 1. Step 2, plug it in. Step 3, write it as an ordered pair. This time I'm not giving a graph, but that's okay. A is negative 3, B is 6. So x equals negative 6 over 2 times negative 3. 6 over negative 6, and it's negative in front. Negatives canceling out. X equals 1. Okay, so that means we plug it in. Negative 3, 1 squared plus 6 times 1 minus 7. So that means we got a negative 3 plus 6 minus 7. So positive 3 minus 7, negative 4. Write it as an ordered. So that's step 2. Write it as an ordered pair. My final answer, 1. Sorry, that's not the negative. 1 coming from the axis of symmetry. Negative 4 coming from plugging it in. There's my answer there. Okay. Try one again. Try that one. Again, each one of these that I tell you to try should be in your notes. And I am going to check notes. So we've got x equals negative b over 2a. That's step 1. So we got a is 1, b is negative 4. So x equals negative 4 over 2 times 1. So x equals negative 4 over 2. So those negatives cancel out, leaving just a 2. So, I can come down here to step 3 and say 2 comma something, right? So let's plug it in for step 2. 2 squared minus 4 times 2 minus 10. That means we got a 4 minus 8 minus 10. Okay, we got a negative 4, negative 10, negative 14 is my answer. So there's my vertex. Okay. Again, pause where you need to so you can copy down. All right, then we got a word problem. Now, what you're going to find throughout the rest of this chapter is that, parabolas are one of the most real-life equations that you could ever get. Yeah. Everything thrown, everything tossed, any projectile-style motion is all based on quadratics. A lot of sales reports are based on quadratics because at some point, you keep making some of something and demand goes down, and then the price, the revenue is going to go down. No, I don't want to. So there are a lot of things that are modeled by this sort of quadratic motion. Yeah. So we're going to have a lot of word problems in here. Just like this one, the graph of this function, there it is, f of x, can be used to model the height in meters of an arch support. So like we got a bridge here. Here's my arch support for the bridge, where the x-axis represents the water level, bloop, 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 and the y represents the distance in meters from where the arch support enters the water. where the arch, can a sailboat that is 14 meters tall pass under the bridge? So I got my sailboat coming along. It's going to try to fit underneath. It's 14 meters tall. Can it fit? Well, I need to figure out how high the arch is, right? What point is that called? Oh my gosh, it's called the vertex. Yeah, we got to find the vertex of that, because then we're going to see, okay, is that 14 meters from here to here? If it's not 14 meters, bad news, right? So let's check the vertex. So first step, negative b over 2a. We know how to do this, just like ones before, but now these got decimals. That's okay. We've got negative b over 2a. So a is negative 0.06. b is 0.6. Watch out for those zeros. So let's see what happens. Oop, don't jump on me like that. So x equals, we got negative 0.6 over 2 times negative 0.06. All right, I think I have to get my big calculator here. Let me jump. No, there we go. I gotta get this guy here. Hold on one second. Get this guy out of here. No. Okay. So we've got a 0.6 divided, oops, I forgot my negative. Negative 0.6 divided by, and I'm going to put parentheses, 2 times negative 0.06. There we go. See, that's, I'm going to plug that in. 5. Positive 5. Okay, so it's 5 comma something, right? So let's see, what comma something? Plug that in. It's negative 0.06 times 5 squared plus 0.6 times 5 plus 10.26. Let me just double check that I've entered this correctly. Negative 0.065 squared plus 0.6 times 5 plus 10.26. Good. So we got 11.76. 11.76, because we plugged that in, right? Now, can my 14-foot sailboat fit through? Uh-oh. Oops. No. The sailboat will not fit. It's getting about a little over 2 meters short. That's a bummer. Okay. So there are your notes for today. Remember to pause wherever you need to so you can copy anything down. And we'll go from there. Again, make sure you have all of the notes copied. I understand this is a difficult topic, folks, but you know, you gotta, the nice thing about doing these videos is that you can always go back and rewatch them. I am going to re-explain stuff on Friday. Don't worry. We're going to review sections 9.1 and 9.2. So don't worry, but you better have the notes all done. Better have the notes all done. All right. See you later, folks. Let's get this in here.